Today we'll discuss univariate analysis. As outline of the lecture, there are 3 points: frequency distributions, charts or graphs, and summary statistics. Let us start from the definition of univariate analysis. Univariate analysis is a statistical method that involves analyzing a single variable. Its purpose is to understand the distribution of values for a single variable. It's typically the first step to understand the data set. Univariate data requires analyzing each variable separately. The analysis only accounts for one variable effect on the dependent variable. Univariate analysis is useful for finding patterns when looking at Gaussian, standard deviation, mean, mode, and median. There are 3 common ways to perform univariate analysis. 1. Summary statistics. 2nd, frequency distribution. 3rd, charts. The most common way to perform univariate analysis is to describe variable using summary statistics. When we talk about frequency distributions, another way to perform univariate analysis is to create frequency distribution, particularly using by table. This one is through graph. Charts or graphs, that is the other one, and we use in this case like box plots, histograms, pie charts, like that. Let's see this one by example, demonstration and explanation by using example. We'll see this spreadsheet, the spreadsheet of data set for the first time before importing our data. A spreadsheet type of file is created by programs such as Excel. For example, maybe in Excel we can save file into comma separate values format in terms of CSV file. STATA reads this type of data using in-sheet command. For example, there is a data which is taken from a data set. Then the first step is you have to see the detail of the data. For that, one step is to describe. If you describe the data, like name of variable is there, again observation or sample size is there, variables, the number of variables including variables is there, again value label is there, variable label is there, also another information including the data, where the data collected, the year of the data collected also there. Addition to describe, you can use summary. We talk about the summary of the data. Again, particularly in the case of continuous variable, you get more information, like the number of sample size, mean of each continuous variable, standard deviation of each continuous variable, minimum and the maximum. On the other hand, both the above description can be explained by using the STATA command name codebook, that is codebook compact. More details about the data. What makes it different from summary statistics that in the case of codebook compact, there is a label. This description is there. For example, an individual may not understand what wage is because it's maybe new for him, maybe it's new for her. In that case, wage means when you use codebook compact, where it is integrated in the data, wage is the earning of daily laborers. What about education? Education of respondents is measured in many years of school, like that. The others also. What's attitude index? Attitude index means attitudinal index of household's head. You can describe in that case. Such more information is founded by using codebook compact. The other, you can generate new variables in order to again, now your variable distribution of your variable, you can create new variable. In order to create, you can use this command, extended generate. Extended generate means simply writing EGEN command on your STATA. For example, simply you can write EGN. AV means average of wage, which is equal to mean of wage. Maybe you can say by location or by other variable. The second point is about frequency distributions. You can talk about frequency distributions of each variable by explaining through table, particularly, for example, sex in terms of table. This one is male and female, frequency is there. Then this one is the percentage of that. This one is again the accumulation of this percentage. Yeah. Second example in terms of table, table in terms of family size. For some family size, those are the number or size of family of the respondents. This one is the frequency, against a percentage, and then the cumulative percentage is there. On the other hand, we can explain by using graphs or charts. One is through histogram. You can write command known as histogram wage if you want to know the distribution of wage among the respondents. Histogram wage, you will get this one. This implies that there is normal distribution. Somewhat some individuals get more wage, many of them medium, again many of them the lowest one from this data. The horizontal line represents wage earnings of daily laborers, while the vertical line represents density. On the other hand, we can use the other command known as graph box. The graph box command can be used to produce a box plot which can help you examine distribution of wage. If wage were normal, the median would be in the middle of the box, 25s and 70s of percentiles, and index within 50s or 90s percentile would be equivalent from the box. The box plot for box shows positive skew. The median is put to low end of the box, and 90s, 95s percentile is again stretched outway from the wage. You can see this graph. This graph is an example graph box wage. The vertical line represents wage earnings daily of workers. Again, the horizontal line represents the distribution. So you can see it's somewhat again low level. Okay, let's see the second one is by using some criteria. Graph box of wage by some criteria. I mean, you can say location, you can say or gender. Then compare and contrast those two graphs. There is some difference between them. In the case of female, this one is the lowest one in terms of wage earnings. This implies that in average, females got less wage relative to male workers. Again, you can explain your graph by using graph pi command, the variable you want, in this case wage. Maybe you can use as criteria one variable, let's say location. Then you will get the answer this one. The this one is the case of urban, the blue one. The red one is or brown one, somewhat is rural area. The other is again through bar graph through bar. You will see this through graph. If you write the graph like this, you will get those graph. This means graph bar over family size title family size by wage. This implies that we are showing the percentage and the family size in this respondent. Again, it implies that there is a normal distribution, family size by wage. You can see like this. The other is a very important one about descriptive statics, summary statics, or descriptive statics or summary statics. We have two approaches in this case: measure of central tendency and measure of dispersion. Under measure of central tendency, we have mean, median, and the mode. The case of measure of dispersion, we have range, standard deviation, and variance. If we start from mean, mean, also known as arithmetic average, is found by adding the value of the data and dividing by total number of values. For example, the mean of 3, 2, 6, 5, and 4 is found by adding those numbers, then divide for their number size. That is 3 plus 2 plus 6 plus 5 plus 4. The number is 1, 2, 3, 4, 5. After that, you get 4. Mean is 4. Average is 4. The other mean mathematically or in statistical definition can say that simply the summation of each observation divided for their size. On the other hand, in the Greek letter, it is represented by mu. So for the population, you can use this one in capital. This one is again mu. It can be calculated in this case in case of population. This one is in the case of sample. In the case of STATA, you can use mean command simply in order to calculate mean of a given variable. You can use extended generate. Let's say the name of what you generate, average of which is equal to mean of which. You can separate again by some criteria you variable by itself. For example, in this case, simply generate or extended generate average of which as a whole, as a total of your data. But in this case, generate or extend generate the average of which in terms of family size or in terms of location or in terms of other variable, you can say. So this one is continues what we see before. We can calculate mean in simple way in this case for sample size, what we said before. So others in case of median. Medians is, by the way, it is halfway point, the data set. Before you find this point, data must be arranged in the order. When the data is ordered, it is called data arrangement or data array. The median either will be a specific value in the data set or will fall between the two values. Midpoint value means the arrange data from the lowest to the highest to identify mid value. If two mid values take the average, that means if it is even number, the arrangement is even number, the number of arrangement even, you can divide the mid ones by 2, then we'll get the median. On the other hand, you can type the command like median simply the command. For example, you want to generate median of which, this one is the name of the variable median of which is equal to median, the variable you want. In this case, median which, median is equal to the median of the variable you want. Second case, if you want to more information, for example, you want to categorize in terms of location, the median which you can use comma by location, or if you want to identify by gender, again you can write here the other variable. The other one is mode. Mode is the value that occurs the most in the given data. Is more occurs, you can say that is mode. To check the result, use command tab or simply write mode. Mode which means the name you are creating, the name you are generating. This mode is derived from the weight, let's say. Assume we have 3 types of graphs. In the first case, mode is greater than median. No, mode is less than median. Median is less than mean. Mean is greatest one in this case. In the second case, 3 of them are equal. In the again third one, mean is less than the others. In the case of the first one, when mean is greater than the others, it's going to be like this one, positively scanned or right scanned, you can say. In the case of this one, they are equal, 3 of them, that is symmetric. This one is asymmetric, both of them. In the case of this second, negatively scanned or left scanned, because mean is less than the others. What does it mean if we say positively scanned? Positive screen or right screen distribution, the majority of the data value fell to the left of the mean and clustered at the lower end of the distribution. The third is to right. Also mean is to right of the median and the mode is to the left of the median, as we explained in the graph above. In the symmetrical distribution means if 3 of them are equal, the data values are evenly distributed on both sides of the mean. That means the largest data than of mean, and the lowest data of less than mean are right left distributed evenly. In addition, when distribution is unimodal, the mean, median, mode are the same as the center of the distribution. When the majority of data values fall into the right of the mean, the cluster at the upper end of the distribution with the tail to the left, the distribution is said to be negatively skewed or left skewed. This means mean is left of the median and the mode is to the right of the median as read before. The other important one is measures of dispersion. Yeah, this dispersion is about range, about variance, about standard deviation. It measures the amount of variation in the data. Similar measures of central attendance may come from very different distributions. Simple example. Assume we have two brands, brand A, brand B. And brand A, we have some distribution, 10, 60, 15, 30, 14, 20. Brand B, 35, 45, 30, 35, 40, 25. The question is calculate the mean of brand A and B. Is there a difference? The distribution of variables are different. Can be the same mean? Let's see. The mean of the brand A is equal to the summation of x's. That is, if you sum, it becomes 210 divided for 6, 35. Same is true in the case of B. The summation is 210 if divided for 6, 35. Again, we can change the above into graph like this. It remains the same, but different in proportion. This one is somewhat broad, this one is again narrow, as you see. Such difference can be explained in terms of variance and standard deviation. We talk about range. It is the difference between maximum and the minimum. Simply, range is equal to maximum minus minimum. Variance is the average or scale of distance each value from the mean. The symbol for the population is known as lowercase sigma. Sigma is equal to the summation of each variable summation minus mu whole square. This represents mean divided for n. N is population size, where mu is population mean, x represents individual value. In the case of standard deviation, simply put this one in square and we'll get the value of standard deviation. Question: find the variance and standard deviation for brand B. Second, if the data is very large, how can calculate standard deviation? Is a question. So it asks us manually, we can calculate this. Those are few. We can calculate manually the value of variance, value of standard deviation. But in the case of huge number of sample size, maybe 200 or 100, it's difficult. It asks more time, it asks more effort. You should be patient to answer that question. So we have to use STATA in this case. In this case, manually possible. For example, for this one, simply first step, find the mean. The mean means summation of each value, then divide for the number 35. Second, subtract the mean from each value and place the result in column of the table. So like this. This one is the excess value, then the difference between mean means 35. 35 minus 35, 0. 45 minus 35 become 10. Again, 25 minus 35 minus 10. Then square this one. 0 square 0. 10 square 100 minus 5 square 25, like that. Step 4, find the sum of the square in column C. Column C means this one. Yeah. You can sum 250. Step 5, divide the sum by n to get the variance. This one is the variance. The last one, take the square root to get the standard deviation. This one is manually possible if sample size is small. But in this case, if the sample size is very large, it is impossible. To do that, we use STATA. For that, we use the command known as extended generate std is equal to standard deviation std into wedge. Then you will get this value from STATA. Taken this example. What we see till now can be explained in detail after some seconds. Thank you.